Welcome to our notes today, everyone. We are in 7.4, which is properties of special parallelograms. All right, so we're going to talk about a rhombus, a rectangle, and a square today. Instead of filling in the definition here, we're just going to look at what we have at this part of our notes. A rhombus is specifically a parallelogram with four congruent sides. A rectangle is a parallelogram with four right angles, and a square is a parallelogram with four congruent sides and four right angles. So basically, think of a rhombus and a square meeting up, having a shape baby. A square is a rhombus and a rectangle. All right, that's just sort of how you can think of it. It sounds funny and weird, but it's just a mixture of both. Um, Everything we have here is going to be some biconditional statements here. So a quadrilateral is a rhombus if and only if it has four congruent sides. So you can go either way on this one. Same thing with the rectangle is a quadrilateral is a rectangle if and only if it has four right angles. So if you have a quadrilateral with four right angles, then it's a rectangle. So we have our biconditional statements. The square. A square, if and only if it is a rhombus and a rectangle. So that's the big one here. It has to be both, which means a square takes on both properties. So the following theorems are properties. These first two right here are about a rhombus. Properties of a rhombus are that the diagonals, when they cross, are perpendicular. So that's specific with a rhombus. Also means also specific with a square. And the diagonals bisect the angles. So those diagonals are basically angle bisectors. Okay, so let's think about that right now. Well, not think, but let's just say it. The diagonals intersect at a perpendicular in a rhombus, and the diagonals are also angle bisectors. Remember, these are if and only if. So if you see the angle bisectors of a parallelogram, then we know we're going to have a rhombus. Okay, so properties of a rhombus. All four sides are the same. Diagonals are perpendicular. Diagonals are angle bisectors of the opposite angles. Rectangle, another biconditional. The diagonals are congruent. Okay, it's the entire one. And we also know with a parallelogram that diagonals bisect each other. It just so happens all of them are the same if you look here. Okay, so all that being said, let's practice some stuff right now. Number one says for any rhombus, MNO, now key here says any rhombus, decide whether the following statement is true. So I'm going to draw a rhombus here. To all these sides are the same. M, N, O, P. One thing we know about a rhombus is all these are the same. Now this says MO, they want to know when is this and NP here, when are they congruent? Now, for these to be congruent, that is special to a rectangle. So is that true with a rhombus? Only sometimes, because sometimes a rhombus is a square, and then a square, which is a type of rhombus, is also a type of rectangle, and rectangles are then where you have your diagonals that are congruent. Okay, so only it's a sometimes, and that's if you have a square, okay, because a square is a type of rhombus. Now, the next one says for any rectangle, PQRS. So here's my rectangle, PQRS. And we know this is a rectangle. We have our four right angles. It says angle PQS. So that's this guy right here. Is congruent to RSQ, which is down here. And this is going to be an always. The reason why is because we have a parallelogram, so we know that opposite sides are parallel. And then what happens is this diagonal is a transversal, which creates the two angles congruent because of alternate interior angles. Now, that was really sloppy, so I'm going to quickly rewrite this. Opposite sides are parallel. I'm just going to try to rewrite that so it doesn't look as bad. Opposite sides parallel. And that'll create alternate interior angles because we have parallel lines with a transversal, and these are alternate interiors. All right, let's go to 3, 4, and 5. This is a rhombus. Things we know about a rhombus is opposite sides are congruent and the diagonals make a perpendicular, right? And they also are angle bisectors. So with that being said, here's what I know. If AB is 9, DC is 9, and then BC is 9, and AD is 9, and also these are angle bisectors. I'm going to have a 44 degrees here, which means the whole angle is 88 degrees. Then, because of consecutive angles are supplementary, the whole angle B, this whole angle B is going to have to be 92 degrees. And because this is a parallelogram, that means angle D here is also 92 degrees. The big angle D, big angle B. That's just stuff I know because of a parallelogram. So I'm going to fill in all that stuff. And if you really wanted to, you could write down that these are perpendicular. So BC, if you look here, is going to be 9. That's right from a diagram. And then I got AC is 14. And because we knew they were angle bisectors, and then from here we could do supplementary, I found out that angle A to D to C, so that big angle D here is 92 degrees. Now let's look at next section here. Number 6, we have a rectangle, and we do know is the corners here are right angles. So if we are 31 degrees, this other one's going to be 59 degrees. And because we have parallel lines, we know that alternate interior angles, so this is 31 and this is 59. So we have that. What do we also have going for us is they said that EG, this whole diagonal is 17. So the other one's going to be 17, which would be HF. So let's fill in things. We have, it's asking for angles FHG. F to H to G, that's 59 because we found this complementary angle up here and we have alternate interior angles. So that is going to be 59 degrees. HF, that other diagonal, is 17 because our diagonals are congruent. Then angle EFH, we already had written in there is 59 degrees because it was also complementary of the 31. All right, last but not least, questions 9, 10, and 11. These are squares. So what we know about squares is diagonals are going to be perpendicular because that is a property of a rhombus. We also know that because it's a parallelogram, each of these diagonals bisect each other. So I'm going to have a 1/2 here. But since a square is a rectangle, we're going to have the same measurements on these other parts of this diagonal as well. So PK we have is 1/2. We also know that the angles P to K to N, since it's in the middle, and a square is a type of rhombus, they intersect at a perpendicular, which is 90 degrees. Then M, N, K, so that one I did not draw on here. M to N to K is right here. Now, if we know the whole corner here is 90 degrees, because that is the property of a rectangle, and a square is a type of rectangle, we also know because we have our rhombus, that a rhombus has where the diagonals are angle bisectors. So it's going to cut that 90 degrees in half. So 90 divided by 2 is a 45-degree angle. All right, there's our notes. If you have any questions, reach out. If not, we'll either see you in class or the next video. Best luck on your assignment.